Okay, so on notes 9-4, we're going to be squaring expressions. So we've actually already talked about exponents before. So when it says we need to square each of the following expressions, that just means we're multiplying it by itself. Okay, so number 1, we're squaring it. So that means square root of 5 times the square root of 5. So remember, we've already discussed multiplying radicals. We multiply the insides, which would give us square root of 25. And square root of 25 is a perfect square. It equals 5. So our answer is 5. Now, listen carefully. Anytime you have a radical and you're squaring it, so square root of 5 squared, it gets rid of the radicals, because when you multiply a number times itself, it gives you a perfect square, and then you're going to turn back around and find what that perfect square number would be. Okay? So square root of 5 times square root of 5 is 5. Square root of 100 times the square root of 100 is 100. Okay, so anytime you multiply by itself, it gets rid of that square root. You're just left with a radical. Okay, so number 2 is a little different because we have a coefficient in front. So when we square it, we're just going to multiply it by itself. So I'm going to multiply the outsides. So 7 times 7 is 49. And then square root of x times square root of x is just x. Remember, we just talked about gets rid of the radical, because square root of x times square root of x is the square root of x squared, which would just be x. You could also just distribute that inside. 7 squared, square root of x squared, and then you get the 49x. So whichever way you want to do it. All right, so number 3, we still have a radical and we still have a coefficient. Now, don't confuse this with this being more than one term. This is all one term. We have a coefficient in front, and then we have the radical, which is square root of x minus 6. So this is all one term. We're squaring it. So you can either actually, I'm not going to do that. You can either distribute that squared inside, or you can just multiply it by itself. We're multiplying the outside, so 3 times 3 is 9. Square root of x minus 6 times square root of x minus 6 just gets rid of the radical, so you're left with x minus 6. But you're having to multiply that by 9, so you're having to put parentheses around x minus 6, because now you're going to have to multiply both of those terms by 9. So you're going to get 9x minus 54. So that would be our answer there. So most common mistake on that one is when you're multiplying those radicals, forgetting the parentheses around the x minus 6. So that way you can multiply the 9 times x minus 6. Okay, so number 1, 2, and 3, we only had one term. Okay, even though on 3 it looked like there was 2 because inside the radical there was 2, that's still all 1. 3 and x minus 6 was all under the radical. Okay, so if we're looking at number 4, notice this time we have 2 terms. So when we square 2 terms, we've talked about it before, you should end up with a trinomial as your answer. So this is the same thing as x minus 4 times x minus 4. So you can either use FOIL, or remember we talked about how to do this mentally. We multiply the x's, we get x squared. We add the 2 numbers to get negative 8x, and then we multiply them to get positive 16. Or use FOIL, and then you combine like terms and still get the same answer. Make sure you don't just square x, square negative 4, and you're done. Because anytime you have a binomial squared, it should equal a trinomial. So you might write that down. Binomial, which is 2 terms. If it's squared, it should equal a trinomial, which is 3 terms. Okay, so looking at 5. Notice the minus 2 is not under the radical. If it was under the radical, that would be considered all one term. But we have square root of x and then minus 2. So this is also a binomial. So we're going to square it. All right, so binomial times a binomial, we're going to use FOIL. Square root of x times square root of x is just x. Square root of x times negative 2 is negative 2 square root of x. Negative 2 times square root of x is negative 2 square root of x. And negative 2 times a negative 2 is a positive 4. Okay, so now we're going to combine like terms. So notice on the insides, we can combine those two. So we're going to have an x. That's going to give me minus 4 square root of x, because remember, a radical is just like a variable. We don't change it when we're adding and subtracting. We only add or subtract the coefficients. Then we have that plus 4. All right, so we ended up with 3 terms at the end. So binomial squared equals a trinomial. Make sure you remember that. All right, so this is all going to be one term because it's all under the radical, but then we have another term over here. So there's 2 terms here. We're going to square it, so multiply it by itself. So I'll start out with multiplying the first terms. A radical times itself gets rid of the radical, so you're just left with x plus 1. Square root of x plus 1 times 3 is 3 square root of x plus 1. And then the inside, we get 3 square root of x plus 1. And then 3 times 3, we get plus 9. All right, so we're combining like terms. Notice we can combine the middles. And then also notice we can combine the 1 and the 9. So we're going to have that x in front, plus the radicals would make 6 square root of x plus 1. And then adding the 1 and 9, we get 10. All right, so using FOIL to multiply the terms together, you should get 3 terms at the end, a trinomial if you're squaring a binomial. Also notice these middle terms, those middle terms should always match because you should be multiplying it by the same thing. All right, let's take a look at 7. So we're squaring it. Notice it's 2 terms because this is 1 term and then this is all 1 term there. So I'm going to use FOIL. So I'm going to multiply the 1's to get 1. 1 times negative 2 square root of x plus 3 is negative 2 square root of x plus 3. And then negative 2 square root of x plus 3 times 1, negative 2 square root of x plus 3. Then multiplying the last 2 terms, we have a negative 2 times a negative 2, which is a positive 4, so there's my coefficients. And then we have to multiply the radicals. Square root of x plus 3 times the square root of x plus 3 is just x plus 3. But you have to times it by 4, so you have to put parentheses there. So I'm going to have to distribute. So that's 4x plus 12. And then I can combine the middle terms. So that should be minus 4 square root of x plus 3 in the middle, plus the 4x plus 12 at the end. Now we'll look to see if there's anything else you can combine. Notice we can combine the 1 and the 12. Now all the others, we wrote the x first, then the radical, and then the constant. It doesn't really matter, but I'll just keep it the same. So I'm going to put the 4x first, then minus 4 square root of x plus 3, and then adding the 1 and 12, we get 13. So notice we end up with 3 terms. Okay, so let's look at this last one. So we have one term here. This is all one term. So we have 2 terms that we're squaring. So we should end up with a trinomial at the end. So just multiplying it by itself. All right, so multiplying the 2's, we get 4. 2 times 3 square root of 3x minus 5 would be 6 square root of 3x minus 5. Same thing on the insides. Should be getting the same terms there. And then multiplying the last terms, 3 times 3, we're going to get a 9. And then square root of 3x minus 5 times the square root of 3x minus 5 is just 3x minus 5. So don't forget parentheses around it so you can multiply it by the 9. So I'm going to distribute. So 27x minus 45. And bring the 4 down and combine your middle terms to make 12 square root of 3x minus 5. Then combining, we can combine the 4 and the negative 45. Again, I'm just going to write the x term first, but it doesn't really matter. Then my radical. And then combining 4 minus 45, we would get negative 41. So notice we have 1, 2, 3 terms. So anytime you have a binomial squared, you should end up with a trinomial. So if you go back up to the top, the first 3 examples were just one term. So you were just squaring one term. Okay, so these squaring the expressions will help us once we get to solving other types of equations.